since we've got Sabrina's not here, Cassidy's not here, Caitlin here. Okay, at the end of the class period, we'll see what that's all about.
Are you recording?
To be honest, I don't think you want to watch it.
I'm recording right now.
Can they hear us?
Yes, they can. So on your best. You don't want Cassidy to think bad. All right. I did mention to you when I first went through this that I wasn't remembering what he wanted us to say about numerically defined. But basically, in the other slide that I gave you over here, what he wrote there, he wrote that numerically defined, the inverse is defined to be when the domain of f of x becomes the range of f inverse of x, and the range of f of x becomes the what?
The domain.
The domain of f inverse of x. Remember, swapping the domain and the range? That's what he had wrote there. Okay, wonderful. Graphical, let me do a second stab at a better picture. I think it's better to actually draw the picture first and then make up the points. So let's see, I'll start here and make a line segment that does this, and then I'm going to put points. So let me call this 1, 2, 3, 4, 5, -5, 1, 2, 3, 4. We'll call that point -5, 4. That would make this point -4, 2. That would make this point -2, 3. That would make this point 0, 0. And the reason it's better to do that picture right now the way it is I can now talk about what would the set of points look like for the inverse. What would the inverse points be? Help me out here. You should know that.
It would be
-4, 5.
No.
4, -5.
Yes. 4, -5. Another one?
it would be 3, 2.
Thir-
Or 3, -2.
3, -2. Okay. Another one?
3, -4.
Oh, that was a -2, 3, wasn't it?
No, but
So 3 negative. Okay, we did that one. What was yours?
2, -4.
2, -4. That's this one here, right? So we flipped that one. Is there another one?
0, 0.
0, 0. So let's go ahead and plot those points. Hopefully we see what we were saying we should always see. 4, -5, 1, 2, 3, 4, 1, 2, 3, 4, 5. That would be out here. 3, -2, 1, 2, 3, 1, 2 will be here. 2, -4, 1, 2, 3, 4, about here, and then 0, 0. So if I connect those, let's see. So what was I supposed to see? Graphically, what should I be seeing?
A reflection. Or
A what? Yeah,
a reflection.
a reflection against what? The y what? The y-axis,
Or
x-axis, or a different line?
the y equals 1.
Domain
Or
range.
The y equals to x.
the y equals x.
Yep. Good job. And even though I did it freehand, I think because I did the picture first on the left, I can kind of see it. Yeah, I can see it. So that's what you're going to have happen always with the reflection. In the analytical, we had that one on the nose. When I covered that yesterday, it all clicked to me. I said F, analytically, F of F inverse of X should be equal to f inverse of f of x. I think I called it f and g, remember? F of g is equal to g of f. And the beauty of it, both of those should be equal to what?
X.
X. Which is why y equals x is that line that's in the middle, because that's what happens. Okay? And then you guys had all the right answers on these. Let's see if we can repeat that success. Twice is a charm, because not everybody caught on to the 5 people that were giving me all the answers. So give me the table for f inverse by using this big table.
3, -2.
Say it again.
3, -2.
3, -2, she said, is a point.
And 2, 1.
And what else?
2, 1.
2, 1. Okay, that's where she flipped the x and the y of the f function. You get it, guys? And now we're going to do the, the one for g inverse. So we must be doing exactly the same work. We flip the x and the y of the g function. So what does that give me?
1, -2.
1, -2. I agree. It sounds familiar. And the other was?
-2, 1.
-2, 1. Then this one, we start out with the inside. And we talk about g inverse of a -2, which means if you were looking at the g function first, you would have to look at the y value of a -2 and match it up with the x value, because normally you plug in the x, but since this is an inverse of g, you're technically plugging in a y value. So if you look at the big table that I have circled, what would g inverse of a -2 be?
It would be
The 1. Now, you could also look at the g inverse table. Right here, you could look at this table. G inverse of a -2, since this is g inverse, here's your -2, it also says 1, doesn't it? So it agrees. It agrees with what you did at the top. So then we write f of 1, which is very simple. Now you have to go back to the big table because that's where the f is. F of 1 is 2. And I think we did say that was the answer. Now we go to the other row, find the value of f inverse of f of 1. So you can go to either table you want. But the inside is f of 1, so you need to go to the big table on the top. That's where f of 1 is. F of 1 is
2.
f of 1. We look here, plug it into the f of 1. It is the 2. So I'm going to write now f inverse of a 2. Now you can go to the f inverse table, or you can go up and find the y value of a 2 in the f column and say it's going to be a what? A 1. Or you could go to the 2 on the x of the f inverse table and say it's going to be a 1. So it's the same answer. Moving on. It's getting uglier. You got 2 inverses. G inverse of f inverse of 2. So if you want to just keep it simple, go to the f inverse table and find the x value, that's 2, since you're looking at the f inverse table. Here's the f inverse table, and the x is a 2. So it points to a 1. So g inverse of a 1, now I can go to the g inverse table, since it's already worked out for us, and say the x value of 1, which, by the way, was the y value of the g, but it's the x value of the g inverse table, and that points to a what? A -2. So g inverse of a 1 is a -2. And the last problem, I'll never forget the answer. The answer was does not exist. I'm never going to live that down since the very first time that I was confused with it. Because I'm looking at it very carefully, and I said, okay, g inverse of 1. Looking at the G inverse table, that's easy. G inverse of 1 is a negative 2. So I'm really happy, and I write F inverse of G of 2. And now I got to go find G of 2. Well, that goes at the top table. G of 2, was I right? G of 2.
Yeah. Or,
Negative 2.
Oh, yeah, I see a negative there. Negative 2 is what? G of a negative 2 is 1, right? So that's F inverse of 1. So let's go to the inverse table, since it's there. Inverse of F, and lo and behold, what's my problem?
There's no value in it.
There's no X of a 1 in the inverse table. And for that matter, go up to F. There was no 1 for the Y values either, was there? So that's how we say, does not exist in my tables. So for the functions that I have, it didn't exist. So we had those right yesterday. Yeah, I cleaned it up a little bit. It came from this analytical definition of inverse. You know, the composite stuff, F inverse equals to F inverse of F equals to X. So you can pick one of those sides and use it. And I can't remember which one I picked the other day. Let me look at what I'm looking at. F of F inverse equals to X. I think I'll pick the first one. That looks more simple. I did actually, because it helped to practice it again. So I'm going to pick yesterday with B-Day. Let me erase all this gobbledygook that I have on here. Some of it was good. Some of it was mediocre. And then right about the time when it was frustrating, I realized that I probably didn't help. And I've noticed that these last few days. This has been, doctors clear you and doctors tell you everything's fine, but I think they lie. No, I think what it is we don't have enough information. And I think there's a lot of people that are still suffering from things. I was talking to a teacher today, and their brother-in-law, they had COVID like 6 months ago. And to this day, he still has problem breathing sometimes. That's kind of scary. All right. We started out with the fact this statement here, it came from that first page. Let me go find it again. Did I do F of F inverse of X equals to, why am I trying to memorize it? It's written right there. F of F inverse of X equals to X. And now what we have to do is do the derivative of both sides. And if you recall, it was either Cassidy or it was Jillian who said, I know one side the answer is 1. Who was that genius?
Probably Cassidy.
That was Cassidy. She was right on the money, right? So now I have to do the derivative of this side. And you have to remember, guys, this is a composite function. Just like when we did G of F of X, we had a big function on the outside called G. We had a little function on the inside called F. And if I was going to do the derivative of this function, I had to do the derivative of G and keep the inside, F of X. Then I had to take that answer and multiply it by the what?
the derivative
Of the
inside.
inside. That's called what rule?
The chain rule.
That was called the chain rule. So that means the big function is the F, And the little function on the inside is the inverse. So the answer becomes f prime, keep the inside of f inverse of x. Now multiply by the derivative of the inside, which looks like this, f inverse of x. And I'm going to put it in parentheses and put the tick mark to stand for derivative. Must be equal to the one that Cassidy said. And the reason that helps out is because I want to know what the derivative of the inverse is. So I'm going to shade it in yellow. Here is the derivative of the inverse notation, right there. I'm going to solve for what I just shaded in yellow. That means I'm going to divide both sides by, wrong pen. Divide both sides by f prime of f inverse of x. Divide that side by that and divide the one by that. F prime of f inverse of x. 1 divided by f prime of some number. So I'm going to write it up here so I can erase it from down there. F inverse of x derivative is equal to 1 over f prime of f inverse of x. Okay, so we weren't really using that on Monday. That's where my brain fog came in. I was doing the denominator, but I wasn't putting it in the whole fraction. So let me get rid of this is in my way. All right, I am not going to break apart this equation of a line and talk about its slope is constant, whatever. I'm just going to pretend it's any equation in the world. F of x is this equation. He's given me an ordered pair, which, by the way, he didn't have to, but he did. And he's asking me to calculate the derivative. See the derivative mark out here? The derivative of f inverse evaluated at -4. Now, you think that stands for x, but it doesn't. That's an inverse. This number really means y. So if I go to it means y of my original function. So here's my original function. The y value must be the -4. So when I plug the y in, I get a -4 equals to 3x plus 2. You're going to see why I need to know what x has to be. So please solve this for x. What do we get? X equals a -2. Now that may not mean anything to you at this moment, but remember what the definition is of the derivative. I need to say that f inverse of the -4 derivative must be 1 over f inverse of, now we're going to say, okay, we said that the x value is a -2, and there's my f prime of a -2. F prime of a -2 is what would go there. It's the x value that your inverse was pointing to. I need the derivative of the normal function f at the x value. And since he was so nice enough to tell you that f prime of a -2 is 3, then we know that the final answer is 1 over 3.
Yeah, so that's what I wasn't getting.
Now, well, because I decided to use my free spirit and say to you guys, why are we doing any of the work? It would not have mattered what x of inverse he was asking me for. He could have said F inverse of 5, and I'm going to get the same answer. He could have said F inverse of negative 100. I would get the same answer. Because the derivative of F was always going to be 3. No matter which ordered pair I'm using. So it was my fault for talking about that instead of just looking at it mechanically and saying, I need to get the x value of the original function gets plugged into f prime of something. Because it looks very complicated up here. But you got to remember when we say f inverse of x, that's actually the y value of the inverse, which means the x value of the regular function because of that switching around. So that is kind of confusing. And be honest with you, they don't always give us a function. So sometimes you have to piecemeal it. All right. I think, wasn't that where we were kind of, well, we kind of didn't get past that really. You guys were already like, if you had tomatoes, I might have walked out with tomato sauce, maybe. Which why I went home and had spaghetti, because it made me think of spaghetti. So here's this big table. And I was looking at what was being told to me about the different values, and you guys were telling me the right things. But you weren't telling me with confidence. You were like, is it this or this? But I think you were on the right track. So now that we've gone through it one other time, let's see if we can break this apart. Find the value of f inverse of 3's derivative. So one thing that I did not do on Monday, I didn't write this out. That f inverse of a 3 derivative is equal to what was the formula? 1 over f prime of something. So the question is, what is that something that I have to plug in? So we have to go and figure out what f inverse of 3, when I go to the table, what's the x value that f inverse of 3 would have been? This is f, not f inverse. Exactly. You have to switch it in your head, and you're looking for the y value. And just like I did when I plugged in that y value and I solved it for x, you just plugged in the y value and you solved it for x, 1. So f prime of 1. Beautiful, done. And I heard conviction there from at least 2 people. I would love to hear conviction from 5 people. That'd be a good, like a quorum that we can make decisions. But now I got to go to the table and find out what f prime of 1 is. F prime of 1 is, how much?
2.
The same 2 people. Can I hear another voice? F prime of 1.
2. Yeah, 2.
Okay.
So wait, so last time we said it was 2, like that was the...
I know, because I didn't write we did the denominator.
But it's actually 1/2.
Well, yeah, I didn't have that's where my brain fog came in. I didn't write the whole fraction. That's on me. That's why I gave you a clean copy. 1 over what?
2.
2. All right, let's see if we can continue this geniusness. That was on me, Yannick. I didn't write the formula down, which is kind of dumb since we spent so much time deriving the formula. I didn't write the formula on the paper. I was worried about f prime of 1, which wasn't the final answer. It was part of the answer. So I apologize, guys. Find the value of g inverse at negative 2 derivative. So let me write it out. Let me be not like I was. I am feeling better today. I was even better yesterday, but it's a slow process. G inverse of a negative 2 derivative must be equal to 1 over g prime of some number, x, has to be an x value from the original function. So let's see. Can we play that game again? What is g inverse of a negative 2? Well, I don't have the g inverse column. So I got to use g and look for the y values that's in g that's a negative 2 if there is one. There is one. What is the x that goes with it? 1 again. So I need g prime of 1. So g prime of 1, wait,
Wait, isn't it,
One.
wait, isn't it, wait, never mind.
are you confused why I circled the negative 2
No, I got it.
in the g? Because that's a y value in the g, and it points to the x value, which stands for the y value of the inverse.
Yes.
Okay, so Jillian said that the g prime of 1 is 1, so that would give me a 1 over 1, which is 1. I kind of think that's the answer. I think I've seen that before.
Last time we got a one.
Oh, we had a 1 anyway? Well, because we didn't use the numerator anyway.
Yeah.
We got lucky, right? All right, moving on here. Let me erase. Well, we didn't do much over here, but I'll still erase it. Oh, we didn't get started. By then, we were saying, let's just quit. Because there was definitely a sense of this stuff's confusing, and then it didn't help that I didn't write the numerator. I didn't realize I didn't write the numerator until I was teaching it yesterday, and I go, how come I don't remember having a fraction yesterday? And I went and looked at that. I said, what the heck was I doing? All right.
We went through it a lot faster
Yeah.
this time too.
Yeah, that's not wise when you're out of it. Got a big table here. It's as big as the other table. Both f and g are differentiable, so the derivatives are there. Find the value of the derivative of g inverse at 1. So let me write out the definition so I don't do anything stupid, which this does not guarantee it, but it may help. G inverse of 1's derivative is 1 over g prime of some number. So since I have the y value is going to be a 1, this is a y value. This right here is a y value. This 1 is a y value of the g. So let me find it. G of a, is it a 1 I said?
Yes.
Let's see, is there a 1 in this column? What's the x that it points to? 3. So the answer will be 1 over g prime of 3, 1 over g prime of 3 is negative 2, negative half. Okay, I didn't follow the directions. He said find the value of this, then find the equation of the line tangent to the inverse graph when x equals to 1. What did I just find if I'm doing a tangent line?
The slope.
Okay, this is called the slope of the tangent line. So we're half done. Because remember what the equation is. Y minus y1 equals to the slope, that's this right here, times x minus x1. And x1 must be this negative 1 right here. So that's already going to be done. Minus minus 1. What am I missing?
The y.
The point of tangency. So point of tangency will come from where?
The table.
Probably. But what would it be? What would y1 be? How would I use a table?
It'd be the y1 of the, it'd be the y of the original function.
Would it be negative 2?
I don't know. I think it has to be g inverse of 1.
Yeah.
That's what I think it has to be. So I will check to see if G inverse of 1 is anything you had just said. I go up to G. The Y value is a 1. What X does it point to? The 3. Did I hear that as an answer?
Oh, I said -2, but it's because I didn't know about the.
Oh, you were looking at G prime maybe, or what?
No, I was looking at, since they gave x equals 1.
You went 1 goes to the G. Oh, okay, so you had the wrong ordered pair, right? Because the Y value had to be the 1. And then, of course, okay. So that's going to be a 3. Man, where's my water? Over there. I'll just chew on another cough drop. That's another thing. Comes and goes. Okay. Oh, yeah, it is a 1. Jillian said Y minus a 3
Yeah.
equals to the
-1/2.
-1/2 times X minus the 1. Perfect. I agree. Second one. Estimate the value of f prime of 2. What does f prime of 2 have to do with inverse? Want to have a table up there of values?
I have no
One.
clue.
Does it have anything to do with the inverse?
Yeah.
It says estimate the value, but doesn't it?
What if I asked you to tell me what the f prime of 0 is? What would you tell me?
It's -1, but they don't give a 2.
So hold on. You said it's a -1. Did it require the inverse to give me that answer?
No.
What if I asked you for what is f prime of 3? What would you tell me the answer is?
-3.
Down here. So if I'm asking you for f prime at 2,
You have to go between f prime of 1 and f prime of 3.
oh, because the x value would be here. Does it have anything to do with inverse, or is this something we've done before?
Something we've done before.
Something we've done before. Had nothing to do with inverse. It has to do with the secant line. Remember? Yannick said that 2's not on the table, and he's finding 2 endpoints, a 1x and an x being a 3. And the y values are corresponding to a 2 and a -3. Those are 2 ordered pairs. One, I'm sorry, where am I looking at? Wrong one. I'm looking at, those are not the right ones I circled. What were the y values? I circled the f prime. I need to circle the y values. 1, 3, because you told me it's between the 1 and the 3, right?
So for the
So it has to be, x has to be between these two. So wherever these points are, it's connected to those. Do you remember we did the secant line? If I was to graph it, 1, 3 was here, and 3, 1 is here. And we want to know what the slope is at 2 right here, right? Well, can't we talk about the secant line? And we had this saying that we said that the slope of the secant line is the approximate value of the derivative between those 2 endpoints. If you knew what the slope was between those 2 points, you would have an approximation for the derivative there. It's not perfect, but that curve could have done this. That curve could have been like this, right? And if you're approximating the slope at 2, well, what's going to happen is, if you think about the slope of this function parallel to that secant line, there's always a slope of the tangent that is equal to the slope of the secant. So that's all that we're doing. Whenever you have a missing x value, like here, we're missing the 2, then we have to say that f prime of 2 is going to be approximately the slope, I'm going to write the words, slope of secant line with the endpoints that we have been given us, okay? So that means y2 minus y1 over x2 minus x1. What is one of the y's that I circled?
1,
What's the other y?
3,
Over, what's the x that goes with the 1?
the x that goes with the 1,
Yes.
3,
What's the other x?
1.
So you're telling me it's a negative 2 over 2 or a negative 1.
Yeah.
Does that little line that I draw look like it could have a slope of a negative 1?
Absolutely.
Oh, thank you. I wasn't really expecting that much encouragement. Thank you very much. It's an approximation. It's not the exact because we don't really know what's happening in that curve. All we know is that it's differentiable and continuous. So it's going to be something like that. This was kind of weird.
Wait, what about?
Oh.
The conclusion that
Oh, what, based on this value, what conclusion can be reached about the graph of f when x is 2? Okay. What can you tell me? What is the graph doing at that place?
At where? Oh,
At x is 2, which meant you were saying that the derivative was a negative 1.
is decreasing.
That's it. That's all you can say. Perfect. You can say f of x is decreasing at x equals to 2 because f prime of 2, we know for sure it's less than 1. I'm sorry, yeah, less than 1. I should say less than 0, right?
oh yeah.
Less than 0. No matter what that picture looks like between those 2 points, it still has to be a decreasing function there. Because look at those 2 dots. From left to right, it has to be decreasing. Good job, guys. Estimate the value of g prime of a negative 1. Based on this value, what conclusion can be reached about the graph of g when x is negative 1? Well, that doesn't look like it's any different. But I'm going to go up there and look for g. G of 1. What?
But it's the inverse of the slope.
Oh, is that what it said? Did I read it wrong?
No,
No, but
it's not the inverse. It's the same thing.
Oh, I'm sorry. It's not g of 1. It's g prime of a negative 1. Is negative 1 one of my x values?
No.
So can somebody else tell me what Yannick had us do? Show me that somebody else who hasn't said anything can tell us what Yannick said we had to do. It's almost like he invented it. Matter of fact, we're going to call it the Yannick method from here on in. Negative 1 is not one of my x's. So where must I go?
In between 0 and -2.
I'm going to have to go in here. Absolutely, in here. So I need to use these 2 x's. And what 2 numbers would I use for y's? 3 and 2? Over here? Those are not y's. Those are actually derivatives at these different places. That is the biggest trick that people mess up on. They think that I can approximate the derivative by looking between 2 derivatives. You can't do that. You can only look at the segment between the 2 points and see what the function is doing, not what the derivatives are doing. It's It never does, it never works. A lot of people have tried, but it never works. You need to only concentrate on the G. This is the mistake that a lot of people do. Yours truly tried doing that many, many years ago, thinking that I could just take the average of the slopes. And I couldn't figure out why it didn't work. And then somebody slapped me in the head and said, you can only look at the function itself to get an idea of what the function is doing. You can't look at all the different derivatives because they change so fast. From point A to point B has nothing to do with each other as far as their slopes. But the motion of the graph, you can tell something about.
So then do you have to do the inverse after you calculate?
I'm not even doing the inverse. Again, this problem doesn't require the inverse. We're just looking at 2 points that make a secant line, and the 2 points are -2, 2, 1, 2, 1, 2, and 0, comma, -3. 1, 2, 3. He's asking me for what's happening at -1. I don't know what's happening between -1. But look at that dotted line. I can definitely say that between, because I don't know, I have no idea what's happening between the -2 and the -1. I have no idea. Let me shade that in. I have no idea what's happening for real there. And I have no idea what's happening outside of here. All that I do know is that between these 2 points, in order to go from point A to point B, the function had to be doing what? Decreasing. Because why? The slope of that secant line is what? Negative. So not only can I say it's decreasing, I can get an approximation because the slope of that secant will be approximately the slope of the continuous function that could have gone through those 2 points. That slope of that secant will be approximately the same as the derivative of that function in there. So I just need to do the slope formula of those 2 points. G prime of a -1 equals to, give me one of the y values that I circled.
2.
Give me the other y.
-3.
Give me the x that went with the 2.
-2.
Give me the x that went with the -3.
0.
A 0. That looks to me like a 5 over a -2, which would be a -5/2. And by goodness, it definitely is negative. So I'm going to say that g of x is decreasing at x equals to a -1, since g prime of a -1 is less than 0. It's kind of not fair that the author threw in these last 2 problems that had nothing to do with inverse.
It was a trick.
Welcome to the AP exam. You know, you just never know. It's like life is a box of chocolates. You just never know what piece you're going to get.
Yeah.
I should market that phrase.
I've never heard that one before.
Never, right? Isn't it cool? Maybe I'll make a shirt. Everybody say goodbye to Sabrina, Caitlin, Cassidy, Daniela. Oh, Daniela, I didn't even say hi to her in the beginning. Sorry, Daniela, don't take it personal. Anybody else?
Henry.
Henry, life's not the same without Henry. All right. Over and out. And that's it.